Hi class, welcome to our lesson on 9.6. We're solving rational equations in this lesson. So whenever we solve an equation, our goal is to isolate the variable, or get x all by itself. So that's true of this lesson. We want to get x all by itself. Now we have a variable in the denominator, so that's why it's a rational equation. Rational functions have variables in the denominator. So with this one, the very first thing that we need to do is we need to identify what x cannot be. You can never ever divide by 0, so x plus 2 cannot equal 0, because then you would end up dividing by 0. So that means x cannot equal a negative 2. So it is possible to get extraneous solutions with this lesson, because if we get x equals a negative 2 for our answer, we would put extraneous solution, because then we would end up dividing by 0. So that's something that we have to keep in mind. So now as we solve for this, we have to eliminate the denominator. And the way we get rid of the denominator is we multiply by the least common multiple. So here we have three factors, 28, x plus 2, and 4. So what's the least common multiple between all three of these? Now 4 goes into 28 7 times. So because 4 goes into 28, you really don't have to worry about this factor. The two factors that we're concerned about are 28 and x plus 2. So the least common multiple of 28 and x plus 2 is those two factors multiplied by each other. So we're going to multiply every term by 28 times the quantity x plus 2. That is our least common multiple. Every term we're going to multiply that, and then our denominator is gone. Watch how this works. This is going to be multiplied by the first term. 28's reduce, and you get 9 times the quantity x plus 2. For our second term, x plus 2 is going to cancel with this x plus 2, so you're going to get a positive 3 times 28. And now for our last term, you're going to get this whole thing multiplied by 3/4. 28 fourths reduces to 7. So now we have 3 times 7 times x plus 2. And 3 times 7 is obviously just 21. So it's 21 times the quantity x plus 2. And now our denominator is gone. So now we're just going to solve what we have left. Let's distribute. 9x plus 18 plus 3 times 28 is 84. That equals 21x plus 42. Continuing to solve, if I combine like terms here, 18 and 84 is 102. So this becomes 102. I'll subtract 9x to get onto this side, and I'll subtract 42 to get onto this side. So 12x would then equal 60. Divide both sides by 12, and I got it made. X equals 60 divided by 12. X equals 5. And there's our answer. And we don't get an extraneous solution because x cannot equal negative 2, and we didn't get negative 2. We got x equals 5. So this is a possible solution. If you wanted to check your work, you could. You found a answer for x, so you could do 9 over 28 plus 3 over x plus 2, which is now 5 plus 2, 3/7. Does that equal 3/4? You can easily check all these in your calculator and see if it checks or not. So I invite you to do that if you'd like to. Why don't you guys pause the video and try number 2 on your own. So again, on number 2, identifying what the denominator cannot be, 3 minus x cannot equal 0. So if you add an x to both sides, 3 cannot equal x, or x cannot equal 3. So if you somehow get 3 to be your answer, it's going to be an extraneous solution. So just like the last one now, to identify our least common multiple, 4 goes into 24. So if 4 goes into 24, we're only worried about these two factors, 3 minus x and 24. So again, just like the last one, our least common multiple is going to be those two factors multiplied by each other. 24 times the quantity 3 minus x. So now let's distribute. Multiplying it by 5 24ths, the 24s cancel, and you get 5 times the quantity 3 minus x. Plus, Now, the 3 minus x's cancel, and you get 2 times 24. And then for our last term, 24 times 23 minus x times 1/4. 24 over 4 reduces to 6 over 1. So it's 1 times 6 times 3 minus x, which is just 6 times the quantity 3 minus x. So now we're solving this equation. So let's distribute to get rid of the parentheses. 15 minus 5x plus 48, that equals 18 minus 6x. Continuing to solve, if I subtract, if I combine like terms here with the 48 and the 15, I would get a negative 5x plus 63. That equals 18 minus 6x. I'll add 6x to both sides, and I get an x. Subtract 63. 18 minus 63 is a negative 45. So I get x to equal a negative 45. Hopefully you guys got the same when you did that one on your own. And once again, you could check your work by putting a negative 45 back in here for x. And we don't get an extraneous solution because we didn't get 3. We got a negative 45. All right, here's number 3. So we got to find all of the factors in order to find the least common multiple. So I'm going to need to factor this to get its factors. So factoring x minus 2 multiplied by x minus 1. So let's identify our denominator, what it cannot be, because you cannot divide by 0. So x cannot equal a positive 2, and x cannot equal a positive 1. So if we somehow get those ones, we cross those out and put extraneous. So we have 4 factors, 1, 2, 3, 4. However, these 2 repeat themselves, do they not? And these 2 repeat themselves, do they not? So we have 4 factors, but really only 2 different ones. So your least common multiple is going to be those 2 factors multiplied by each other. X minus 2 times x minus 1. Those 2 factors multiplied by each other. So we're going to multiply that by every one of these terms. So here, x minus 2 times x minus 1 times this term. The x minus 1's cancel, and you get 4x times the quantity x minus 2. In our second fraction, you have a negative 5x is multiplied by the x minus 2's cancel, so all you're left is with this x minus 1. And now, for our third term, this x minus 2 reduces with this x minus 2. This x minus 1 cancels with this x minus 1, so all you're left with is 2. Now our denominator is gone, and we simply solve for x. Distributing, we would get 4x squared minus 8x minus 5x squared plus 5x equals 2. Okay. Combining like terms, a negative 4x squared, or a positive 4x squared minus 5x squared is a negative 1x squared. A negative 8x plus 5x is minus 3x. That equals 2. Okay, whenever you have an x squared term and an x term, you're going to get everything onto one side, and then you're probably going to need to factor. So let's get everything off to the right. I'll add an x squared. So I get a positive x squared. I'm going to add 3x plus 3x plus 2. That equals 0. Now that we have that, let's factor it to get what x equals. So we have x plus 2 times x plus 1. Each of these factors we set equal to 0 to find what x equals. X plus 2 equals 0, and x plus 1 equals 0. So we have 2 solutions for this one. X equals a negative 2, and x equals a negative 1. So here's our answers. Let's see if they are extraneous. Do either of these 2 make our denominator 0? Well, x cannot equal 2, and x cannot equal 1, and we didn't get that, did we? We got a negative 2 and a negative 1. So these are valid solutions. They will satisfy this equation. If you wanted to check it, you could put both of those solutions in for x, and you would get the left side equal to the right side. So there's number 3. Let's try our last one, number 4. Whoa. There it is. Okay. So, this is the difference of two squares. So let's factor this. It's r minus 1 times r plus 1. This one has a denominator of just 1. So as far as determining what our denominator cannot be, we cannot divide by 0. R cannot equal a positive 1, and R cannot equal a negative 1. If it's either one of those solutions, that would make our denominator 0. So now we have to talk about what our least common multiple is. You have basically 3 factors, 1, 2, 3, but these two are the same. So if those two are the same, all of your different factors are just the r minus 1 and r plus 1. So our common denominator is going to be this, or our least common multiple. So that's what we're going to multiply every term by. R plus 1 and r minus 1. Okay, so on our first one, when we distribute it, this multiplied by r, nothing reduces in the denominator, so we just get r times the quantity, r plus 1, and r minus 1. On our second term, when we distribute, well, now both of these factors cancel with both of these factors. So now we don't have anything left in the denominator, and we just have this r squared minus 5. So plus r squared minus 5. That equals, in our last term, when I distribute this to here, the r plus 1's cancel. So if the r plus 1's cancel, now we have our r squared plus an r plus 2 multiplied by r minus 1. Okay, our denominator is gone. Now we need to simplify and solve what we have left. And it can be a headache. So here we go. This right here, if I were to FOIL it, it would be r squared minus 1. If I FOIL r plus 1 and r minus 1, those are conjugates, you'd end up getting r squared minus 1. So now I'm going to distribute this r amongst both of those terms. And you would get r cubed minus an r. Plus the r squared minus 5. That equals, we're going to have a trinomial times a binomial here on the right side. So r squared, let's multiply it by r minus 1. The first term times the binomial. Plus the second term times the binomial, r times the quantity, r minus 1. Plus the third term times the binomial, 2 times the quantity, r minus 1. Woo! Let's simplify that good stuff on the right side. Distributing, we'd get r cubed minus r squared plus r squared minus r plus 2r minus 2. All of that equals the right side of r cubed plus an r squared minus an r minus 5 if I were to write it in descending order. Okay, let's clean up this mess. This looks gross. On the right side, I would get r cubed. These r squareds are now gone. This makes a positive 1r minus 2. That equals r cubed plus r squared minus r minus 5. Okay, let's get everything onto the left side. Subtract r cubed, subtract r cubed, and what do you know what? Our r cubes are history. That's kind of nice. Subtract r, add 2, add 2. So on the right side, we get a 0 now. On the left side, we have this r squared, we have a minus 2r, and we have a minus 3. Okay, when you see a trinomial with an r squared and an r, we're going to have to factor it. So we get r multiplied by r and a negative 3 multiplied by a positive 1. So now that we have our two factors, let's set both of these factors equal to 0. R minus 3 equals 0, and r plus 1 equals 0. So our answers, r equals 3, and r equals a negative 1. There's our two answers here for problem number 4. Always go back. What can x not be? X, or r in this case, cannot equal 1, and r cannot equal a negative 1. Here we have it. R cannot equal a negative 1, and we got that. So this, my friends, is extraneous. If you keep that circled on your test, I count it wrong because that r equals negative 1 does not satisfy the solution. We only have one solution for this one, and it's r equals 3. The other one is extraneous. Let me know if you have any questions on solving rational equations when you get to class tomorrow.